In this example, you have a truck moving forward with 100 km per hour and this speed is kept constant. There is a launcher on the truck which is used to launch the ball to the opposite direction. So the ball is 1 kg and is launched by 100 km per hour relative to the truck. If you are observer at surrounding, observe the motion of the ball relative to the ground. If all the observer here is in the inertial frame, can you predict what will be the motion of the ball? So you have the truck labeled by T, ball labeled by B, and the observer labeled by O. We can use the velocity equation to find the motion of the ball. In general, we want to know the velocity of the ball with respect to the ground, which is in the inertial frame. So this is not equal to 100 because the 100 km per hour here is the velocity of the ball with respect to the truck. This velocity is a relative value. This is because this measurement is made with respect to the truck and the truck is translating. So you can cancel the rotating effect and simplify the equation into the translating frame. Let's assign the coordinate for this system. So we need 1D. Let's say this is your x direction in positive. Then this will be equal to negative 100 km per hour in the I direction. And then this will be your velocity for the truck with respect to the O, and it will be equal to 100I. By substitute the velocity information inside this equation, then you obtain your V ball with respect to O equal to 0. This means that after you launch the ball, the velocity will be equal to 0 with respect to the ground. So in this case, the ball will not move forward and it will just free fall. Let's look at this experiment. When the truck is moved in 100 km per hour to the left and the ball is launched, you see the ball just free fall to the ground. So why does the ball doesn't move to the right by 100 km per hour? This is because 100 km per hour of the ball is measured with respect to the truck, which is a translating frame. Therefore, you should know the velocity of the ball with respect to the truck here, which is 100 km per hour to the right, is a relative motion, and this motion is not valid for inertial law. Bear in your mind, only absolute motion will be valid in the inertial law. You have obtained the velocity of the ball with respect to O by using Vv/t plus Vt/O, which is equal to 0. So from this result, the motion of the ball to follow the free fall will be valid if you observe the motion in an inertial frame. Besides the velocity, you can also find the acceleration of the ball with respect to the ground to be this equation. Since the truck and the ball are moving with constant velocity, therefore these two terms can be cancelled. You should know constant velocity will give you 0 acceleration here. There is a correction here, so this will be the ohm because this is the angular velocity for the frame. Since you measure the acceleration of the ball with respect to the truck and the truck is translating frame, so you don't have rotating element here, so these three terms can be cancelled. Therefore, the acceleration of the ball is equal to 0 here. If you want to calculate the summation of the force acting on the ball, you can use the Newton's second law. Substitute the absolute acceleration of the ball inside the equation and the mass to be 1 kg, then you obtain the summation force equal to 0. In this case, the truck is a translating system with constant velocity. Therefore, this is a inertial frame as well. So you obtain the acceleration here to be the absolute assertion. As an alternative, you can also use this as the absolute assertion, and you should get the same answer here.